Right, now we will talk about multiplying whole numbers together. Yet again, we are using the place value system, which breaks down numbers into their basic parts. But now what we're going to do is, instead of adding or subtracting these numbers together, we're going to make use of the distributive law. And so let's take an example here. Let's say that we have 3,675 multiplied by 7. What's the, if you have to break down 3,675 into its basic parts, it's 3,000 plus 600 plus 70 plus 5. And then if you multiply 7 to that, now you have a single whole number multiplied by the addition of whole numbers in a bracket. What do? We use the distributive law. Right, so that's why discussing those properties was extremely important. Can you see the way we're using it? Now we can say 7 times 3,000, 7 times 600, 7 times 70, 7 times 5. Now can you see what this enables me to do? When you add this number together, you couldn't see all of this here, right? And so by breaking it down into its basic parts, can you see now you can do 7 times 3, it's 21. Now you can do 7 times 6, which is 4,200. Now you can do 7 times 7, 490. Now you can do 7 times 5, 35, right? And so that's why this is what it enables me to do. We know that 7 times all of these zeros will just be 0, but we can do these basic whole number to whole number multiplications because we've done our timetables extensively. And so what we can do with all of these parts here now is add them together. And then we make use of the addition of whole numbers. So it'll be 0, 0, 0 plus 5 is 5. 3 plus 9 plus 3 or 90 plus 30 is 120. The 2 will come in the tens column, but the 1 or the 100 will go in the hundreds column. So now you have 200 plus 400, which is 600, plus that 100 from the previous column makes it 700. Then you have 1000 plus 4,000, which is 5,000, and then you have 20,000 plus all the zeros will just be 20,000. And so the product or the multiplication of 3,675 multiplied by 7 is 25,725. Now we can do this exact same calculation, but we can present it differently, right? We're going to use the column method exactly as we did with addition and subtraction. And so now when we say, listen to this, exactly as I said, we know how to multiply whole numbers to whole numbers, like 7 times 6, 7 times 7, 7 times 5. We know how to do that. But what comes with it? It's all of these zeros. See, there's 1 0 there. There's 2 zeros there. There's 3 zeros there. And so because we're dealing with the tens, the hundreds, and the thousands column, these zeros have to come with it. So in the tens column, we have 1 0. In the hundreds column, we have 2 zeros. In the thousands column, we have 3 zeros. And so when you're saying 7 times 5, it's 35. When you're saying 7 times 7, it's not 49, it is 490 because you're actually multiplying by 70. And so to simplify that calculation, what we do is we just put these zeros in here because we know that we're not multiplying by 7, but we're multiplying by 70. Let me rephrase that. In this column here, can you see how I broke it down? I broke it down into units, tens, hundreds, and thousands. In the tens column, I'm not saying 7 times 7. I am actually saying 7 multiplied by 70. In the hundreds column, I'm not saying 7 times 6. See, 7 multiplied by 6. I'm saying 7 multiplied by 600. In the thousands column, I'm not saying 7 multiplied by 3. I am saying 7 multiplied by 3000. And so what happens is in your answer, you will have 1 0. Here you will have 2 zeros. Here you will have 3 zeros. And so what we do is before we start the calculation, we put these zeros in here, right? We put these zeros in here because we know that we're going to get these zeros. And then we just do the multiplication straightforward. So we'll say 7 times 5, 35. 7 times 7, 49. 7 times 6, 42. 7 times 3, 21. But we know that it's actually 21,000 because of the placement of the 3. Right? Because the 3 is in the thousands column. In the thousands column, we have 3,000. And then when we do the addition straightforward, we get 5, 120, the 100 goes to the hundreds column. Then 400 plus 200 is 600 plus 1 is 700. 4,000 plus 1,000 is 5,000. And 2 will give you the 20,000 there. Right, so I hope you understand what I'm saying. Right, so now we can do the exact same process, but represent it much more neatly and much more differently. And the reason we use this approach here is because it's for much more larger numbers. So let's say that I had to multiply 3,675 by 307. Now you have a 4-digit number multiplied by a 3-digit number. Right, to do this approach at the top will be extremely impractical. And so we will make use of this approach here, but we have to be very mindful of what we're writing. You see, when I say 7 times 5 is what? 35. And so we have 35. The 5 will go into the units column. The 3 will go where? Into the tens column. And so that's the reason why I write 3 in the tens column, because I am going to increase the tens column by 30. And so whatever I get here, see, 7 times 7 is 49. But it's not 7 times 7, it's 7 times 70. And so what we have there now is 490, right? And so 490 plus the 30 that came from the previous column gives me 520. But what goes in the tens column? Only the 2. The 5 will go to the hundreds column, right? And so what I'm basically saying is that whenever you get a double digit, let's say you get a double digit in the tens column, right? Listen to what I'm saying. You get a double digit in the tens column. So 7 times 7 is 49. 49 plus 3 is what? 52. That 52 is actually 520. So that 5 has to go into the hundreds column. If you're getting a double digit in any column, it implies that the digit has to move to the column to the left. Very important stuff. Let me repeat that. If you get a double digit in any column, it implies that the digit has to move to the column to the left. Getting 52 in the tens column implies that you have 520. Because if I had 52, remember in the tens column we're multiplying by 10. If I had 52, I multiply by 10, what do I have in the tens column? I have 520. But I can only put the 2 in the tens column because the 5 has to go to the hundreds column. If I have, let's do this here. See, 7 times 6 is what? 42, right? 42 plus 5 is 47. So we got 47 in the what column? In the hundreds column. This is actually 4,700. So the 4 needs to go to the thousands column because the placement here is 4, which has to go to the thousands column. And the 7 has to go to the hundreds column. Do you understand what I'm saying? And so if I have to say it a bit more differently, if I say 7 times 6 is what? 7 times 6 is 42, but in the hundreds column, it's actually 4,200. Because if you have a double digit, that means that that digit has to move to the column to the left. And then if you add the 500 that we had from the previous column, that gives you 4,700. And so only the 7 goes to the hundreds column, but the 4 has to move to the thousands column. 7 times 3 or 7 times 3,000 is 21,000. 21,000 plus the 4,000 that came from the previous column makes it 25,000. But 25, we have 25 in the thousands column. We have a double digit. Means that 2 has to move to the next column, which is the 10,000s column right here. And so it'll be 5 will go into the thousands column and 2 will go into the 10,000s column. And so if you understand this, you understand the core and the basics of what we're doing here, then you'll be able to solve any question because you understand what you're doing. You're not just mindlessly writing these numbers here. You know, because I have a double digit in the units column, one digit has to move to the left. Because 35 in the units column means that there's 30 that needs to go to the tens column, right? If I have 52 in the tens column, it's actually 520 in the tens column. So that 5 from the hundreds column has to go to the hundreds column and the 2 has to stay in the tens column. Right? Please watch this video repeatedly and understand what we are doing. Right? Understand what we are doing. Because now when you start working with double digits, it's going to become extremely important. Right, so now let's do the exact same approach that we've just done. But now we're going to work with a 4-digit multiplied by a 2-digit number. So we could do this exact method but present it differently and do the calculation on a single line. This is useful for larger numbers. So that exact approach that I used, that the one that I've just discussed, is what we are going to use when we do multiplication in a column, because it's the most refined and easiest approach to use. Right, so if I multiply 3,675 by 27, right, listen to what I'm saying. What we would do is we would first multiply the units from here to all of these digits here, and then multiply the tens here to all of the digits here. So let's see what we get. See, 7 times 5 is 35, but the 3 has to go to the tens column because we're getting a double digit in the units column. And so we'll have 5 in the units column, the 3 will go to the tens column. Then if I say 7 times 7 is 49. 49 plus the 3 that came from the previous column is 52. So the 2 will go in the tens column, the 5 will go into the hundreds column. 7 times 6 is 42. 42 plus 5 is 47. right? The 7 will go into the hundreds column, but the 4 will go into the thousands column. And so if you understand what I'm saying, this 4 is actually the 4,000 that's going to go there, because this result here, when you say 7 times 600 is 4,200. 4,200 plus the 500 gives you 4,700. And so the 700 will go in the hundreds column, and the 4,000 will go into the thousands column. And so whatever this result you see, 7 times 3 is 21, or 21,000, plus the 4,000 that came from the previous column makes it 25,000. And so you'll have 5 in the thousands column, and the 2 will go to the 10,000s column. And so now we've done with these numbers, so we can scratch it out. All right, then let's work with the next number. Now we're not saying 2 times 5, it's actually 20 times 5. And so what we do is when we're multiplying by 20, we have to put the 0 here. Listen to what I'm saying. We have to put the 0 here. And then we can do the calculation as normal, whole number by whole number. Because you're not multiplying by 2, you're multiplying by 20. Right? And so we have to represent this part differently. It's the same as saying 3 times 6 times 5 multiplied by 2 times 10. Right? 2 times 10. And so what we know is, this is better. You see what you see when you do this here, 2 times 5. You're basically saying this here, 3675 multiplied by 2 multiplied by 10. And so whatever this result is, by saying, say, 2 times 5, 2 times 7, 2 times 6, 2 times 3, which will give you this result here, you're going to take that result and multiply that by 10, which is the same as saying just add a 0. Because if I say 100 multiplied by 10, you're just basically adding a 0. If I say 200 times 10, you're basically just adding a 0. And so what we do is, we know how to do 2 times 5, 2 times 7, 2 times 6, 2 times 3. So what we know is we're not multiplying by 2, we're multiplying by 10. And so we just put the 0 in there, because whatever the result of this product is, we're going to just add the 0 to it. Let me repeat that. Whatever the result of this product is, we are going to multiply by 10. Right, let me explain it. So, watch here. 2 times 5 is 10. 2 times 5 is 10. So it'll be 0 here, and then we carry the 1 to the tens column. 2 times 7 is 14. 14 plus that 1 that came from the previous column is 15. 5 will go in this column, 1 will go to the column next to it. 2 times 6 is 12. 12 plus the 1 that came from the previous column is 13. So we have 3 here, carry the 1 to the next column. 2 times 3 is 6. 6 plus that 1 is 7. And so what we have here is 7,000. But since we're not multiplying by 2, we are multiplying by 20. This number has to get another 0. And so now we have 73,500. And what we can do now is do normal addition and add these two together. So 5 plus 0 is 5. 2 plus 0 is 2. 7 plus 5 is 12. But we're saying 700 plus 500 will actually be 1,200. So the 2 will come to the hundreds column, and the 1 will go to the thousands column. 5 plus 3 is 8, plus the 1 is 9, which is actually 9,000. And 7 plus 2 is actually 90,000, right? Because it's 20,000 plus 70,000. Right, so can you see how we're doing this? Yeah, if you don't understand this approach, right, if you don't understand this approach, what we're doing here is effectively the same as saying, watch here. It's the same as saying 3675 into 20 plus 7. Can you see? 3675 multiplied by 27 is the same as 3675 multiplied by 20 multiplied by 7. And so what we have here now is the same as 3675 multiplied by 20 plus 3675 multiplied by 7. Distributive law. And then if I do each part separately, see with this here, 3675 multiplied by 7 was the same as doing this here, the first line. Right? 3675 multiplied by 20, but what we did, we said 3675 multiplied by 2 multiplied by 10. And so what we did was we multiplied all these numbers here by 2, right? We got a certain result, which was 7,350, and then we took this 10 and multiplied it to that number, to that result. And so now we have 73,500. Right, let me repeat that. Remember, we didn't say 20 times 5. I said 2 times 5, 2 times 7, 2 times 6, 2 times 3. But we know actually what we're doing is we're multiplying by 20. But where that 10 comes from is we're doing that product here. We're adding the 0 here, right? If I gave you this here separately 3675 multiplied by 2, what do we get? 2 times 5 is what? 0, carry the 1. Right, 2 times 7 is 14 plus the 1 is 15, carry the 1. 2 times 6 is 12 plus the 1 is 13, carry the 1. 2 times 3 is 6 plus the 1 is 7. But we know that we didn't multiply by 2, we multiplied by 20. We're not changing the question, we are re-expressing it so that it's simpler for us to do. We're breaking it down into chunks. As opposed to multiplying by 20, we're just multiplying by 2. But we still have to bring that 10 in because that was what was given to us. And so if I multiply this here by 10, if I have to multiply this here by 10, it's effectively, or it is the same as just adding a 0 to the result of multiplying by 2. And so can you see what we did here? This here, 7350, is the same as just multiplying by 2. But I know that I need to add the 0 there because I am multiplying by 10. Because I'm multiplying by 20 and I'm not multiplying by 2. And then what you do is, because all of these numbers now, you have to put them in the correct order. Units, tens, hundreds, thousands, tens, thousands. We can add the result together. So I'll add the result of this, which was here. And I'll add the result of this, which is here. And you should get your final answer, which is, if I go a step above, 3675 multiplied by 27. Can you see how we broke it down into chunks? This is what I started off with. I broke it down into manageable sizes. So 20 plus 7. Then I broke it down further. I said, okay, 3675 into 20 plus 3675 into 7. So this part here we did first. There's it here. This part here, I broke it down further. Because remember, all you're doing is, and this is what they're teaching you, how to multiply whole numbers together. And so you want to work with single digits at a time. So 2 times 5, 2 times 7, 2 times 6, 2 times 3. Like, you think about your timetables. You're going to work with those single digits. We haven't worked with double digits. And so, because we're not saying 20, this 10 has to come in eventually. And it comes in at the end here when we multiply by 7350. It comes in at the end. But we save ourselves the trouble and we write it in at the beginning. Because we know that the units column is just going to be 0. Because we're going to multiply by 10. And that's the same as just saying adding 10 to whatever the result of 2 times 3675 is. So that's 7350 times 10, which is 73500. Right? It's a bit complicated. If you repeat this video enough times, you can understand how we broke this into chunks. And so if I have to color code it here for you, see this here, we did this here, first part. See this part here, 3675 multiplied by 2 multiplied by 10 is actually broken down here. Here's the 10. We did the product of the 10 already. It's hidden, but it's there. We did it. Right? It was systematic and logical. And then now we got the 3675 multiplied by 2. Can you see that? So this part here is shown in 3 different parts. Right, now let's do a 4-digit multiplied by a 3-digit and you'll understand this more deeply. Right, this is how you'll understand it more deeply. What we're going to do first, exactly as I've done before, I'm going to say 3675 multiplied by 327, which is the same as 3675 into 300 plus 20 plus 7. This is the same as, can you see this equal to sign is very important because whatever you write here needs to be a re-expression of whatever's at the top. Let me repeat that. Whatever you write here has to be a re-expression at the top. So see these brackets here? It represents multiplication. Is 300 plus 20 plus 7 327? Yes, it is, because we're using the place value system. Then we can make use of the distributive property because there is such a property in maths. So 3675 multiplied by 300 plus 3675 multiplied by 20 plus 3675 multiplied by 7. What did we do in the first line? I did this part here. There's it here. You would first say 7 times 5, 7 times 7, 7 times 6, 7 times 3. Do your product as we did with the single digit and then we're done. Now you see the second part here. There's it here. This one here. We need to work a bit more strategically. Right? Instead of saying 3675 multiplied by 20, I'll first multiply it by 2 and I'll just add a 0 to the end. Because whatever I get here, when I eventually take this here and multiply by 10, it's effectively saying just add the 0 and whatever this result is, which is 7350, you're just adding a 0 to the end. And so that's why we can work strategically and say 2 times 5, 2 times 7, 2 times 6, and 2 times 3, because I broke it down, I chunked it, I broke it down into chunks. I said, okay, I know my 2 times table, but I don't know my 20 times table. Let me say that again. I know my 2 times table, but I don't know my 20 times table. And so if I can break it down and do my 2 times table first, with the 10 times table, I can just add a 0 to it. Right. When I come to this part here is actually here, and right, so that's here, the yellow part is here. Then if I move on to the green part, which is this 3675 multiplied by 300, what do I need to do? I know eventually, see, 3675 multiplied by 300 is the same as 3675 multiplied by 3 first, then multiply by 100. Because I know my 3 times table, I do not know what's my 300 times table. And so what we know is, if I first multiply this entire result here by 3, I'll get this here. And if I then add these 2 zeros at the end, because I'm going to have to multiply by 100, then I'll get the full result. Right. And so what we have here now is here, this part here. And then when you add the units, the tens, the hundreds, the thousands, the 10,000s, the 100,000s, and the million, you will get 1,201,725. Right. And so, although this may seem a bit complicated to you, if you do, listen to this, watch it again, see how we progress to from this here, right? Check how we progress. Okay, and so now if we take this exact result and we put all together, see, when you did a single digit, 25,725, can you see how it links up? Can you see? First, the first row here is the same as the first row here, which is the same as the first row here. When we did a double digit, see 20 times 3,675, we get 73,500. It's the same. You have to add the 0, right? And we said that we have to break it down into a much more manageable chunk, which is 3,675 multiplied by 2 and multiplied by 10, because you know your 2 times table, but you don't know your 20 times table. And so we have to break this down into chunks. And then we just made use of the simple fact that if I multiply this part here by 2, I'm just going to add a 0 at the end. And that's why we put the 0 there. Then we went on by multiplying by 300. When you multiply by 300, we said, yet again, we're going to break this down into a manageable size. So it's going to be 3,675 multiplied by 3, then multiplied by 100. And so whatever the result of this is, we can just add 2 zeros to the end of it. And so we said that the 11,025, we just add 2 zeros and make that 1,102,500. And so when you add the units, the tens, the thousands, and the hundreds column and so on, you will get the final result. So that's how you progress from single digit to double digit to 3 digits in products.